Hi everyone, welcome to another electronics lab class. This week's class we will be doing two labs, so it's going to be from the lab manual, the DC lab manual. We will do lab number 7, which is the series parallel DC circuit. We will complete figure 7.1 and figure 7.2. Then we will go to the second lab manual, the semiconductor lab manual, and we will complete the LDR, which is figure 1 from lab manual 2. And then we will complete the diode curves, which is lab manual number 3 from the second lab manual. And we will complete figure 1, 2, and 3. So the things that we need for this lab are the LDRs, which I would explain later on, and we have the diode and the resistors that we need for this lab. We need a 1K, a 2.2K, 3.3K, 4.7K, and 6.8K resistor. Again, if you don't have, for example, the 4.7K resistor, you can use the closest resistor that you have, which probably is going to be the 5K resistor. So for the first part, for the first schematic, we have 3 resistors. 2 of them are in parallel and 1 of them is in series with those 2. So this one is going to be our R1. I can put it like this, or I can put it the other way, and it's in series with R2, which is the second one, this one, and R2 is in parallel with R3. So now we see here that this is R1, this is R2, and this is R3. Again, R1 is in series with R2 and R3. These two are in parallel. You can see here that these pins are connected to each other at, I can say this is point D, this is point D, this is point C, and this is point A. So point A, A, B, and C, B and C, which are connected to each other, and D. This is again R1, R2, and R3. Now we can set our voltmeter according to the lab manual. We would set it at 10 volts. We will connect point A, and then we will connect point D, which is the last part. To measure the voltage, again, we need a voltmeter. We can put the voltmeter on DC voltage, and it will be connected to the volt-com port. Then we would measure the voltage of each resistance. By the way, my resistors are different from yours, so you would have different values than I have. I've picked all of them as a 4.7K, but you have to do it according to the lab manual. So if I want to measure the voltage on R1, I will connect it to the input and the output of the R1 and put it in parallel with R1, so I can measure its voltage. So here, I don't know if this works properly, but this is how we measure R1, for example, the voltage of R1. And we kind of do it the same between A and, so this is between A and B, A and C, which would be the same. Let me zoom a little bit. So measuring the voltage between A and B, and then A and C, and then we can do A and D and measure the total voltage that we have. So again, this voltage, we put it in parallel. Then we can put it between A and D to measure the total voltage. If we want to measure the voltage for R2, we would put it in parallel with R2, and if we wanted to measure the voltage of R3, we would put it in parallel with R3. Unfortunately, my multimeter's battery has so I brought another multimeter. Sorry for the delay. So for this multimeter, again, it's the same as the other multimeters. And you can see here that if I connect the voltage from A to B, I am able to measure the voltage of the voltmeter. I'm testing the voltage of. I'm also testing the voltage of the power source to make sure that I have the correct voltage. It seems that this one doesn't work, so I would switch to the second channel. Put it in 10 volts. Okay. So now we can see that the total voltage is around 10 volts. If we want to measure the voltage of R1, we would simply put it like this. In this case, it's 6.6. Yours would be different. And if I want to measure the voltage of R2, I would put it in parallel with R2, and which is 3.3 volts, and R3, which would be again 3.3 volts. The reason is that these two are in parallel, R2 and R3. Therefore, they would share the same voltage. Now, if we want to measure the current going through each resistor, if I want to measure the current at point A, I would disconnect point A, put it in another slot, and then I will put this in current. If you have this type of multimeter, you don't need to disconnect it. This can also measure up to a few milliamps. If you go more than a few amps, you have to switch the terminal. But if you're just measuring a few milliamps, you just keep the black and the red probe in the same terminal spots. So and milliamps, and for measuring the current, we will put the ammeter in series with the system. So again, I'll put this in milliamps. I have to switch this to measure milliamps, and then I will put the current meter in series with the system. So I will connect it and make sure that you have a solid connection between them. So I will put it between the resistor and the input. So as you can see, I've disconnected these two. Now I'm bridging them with the ammeter, and bridging them with the ammeter, we can calculate the current passing through the system. Let me connect it again, and I'll show you how much current we have. So in this particular case, I want to find a way to be able to correctly connect it. So you can see that we have 1.3 milliamps. Now, if we want to measure the current in point B, I will connect resistor number 1 to the voltage source DC. Now I have disconnected point B and C, so I've disconnected the first resistor from resistors number 2 and 3, and I will make a bridge using the ammeter and now we can see that it's around 1.4. It will be the same because these two are in series. Now, if I want to measure the current of each resistors, R2 and R3, I will put R1 back. I will put the source back as well. And here, I would disconnect one of these resistors, for example, R2, I will put it in another slot. And then I will bridge between this resistor and the input. That now you can see the current is 0.69 or 0.7 milliamps. This is the current going through R2. Again, I would disconnect R2 from point B. I would put it in another slot, and then I would bridge it with the ammeters. To measure the current going through R3, I would put back R2. I would disconnect R3. So I will put back, you can see R2, and I would disconnect R3. Now I would put a bridge, I'll put the ammeter between these two and bridge the gap. And now we can see that again, the current is 0.7 milliamps. So adding 0.7 plus 0.7 will give you 1.4 milliamps, which is the total current of the system. The goal of this lab obviously is to see how, when we put the resistors in parallel and series, how would that affect the current and voltage going through the resistors. If the resistors are in parallel, they will share the same voltage, but the current would be divided among them. If the resistors are in series, they would share the same current, but the voltage again would be divided between them. So let's go to the next part, which is figure 7.2. In this case, we want to put R2, R3, and R4 in series, and all of them in parallel with R1. So what I can do is I'm going to disconnect my board again. I will put R1, R2, and R3 in series. So R1, R2, and R3 are R1, R2, and R3 are in series. Then I can connect R1 in parallel with them. So R2, R3, and R4 in series. And I can put R1 in parallel with them. But since I don't have, I can't reach R1 with the other pin, I'm going to use a jumper wire to connect the other end of R1 to the other end of R4. So this is how we connect R1 in parallel with R2, R3, and R4. So you can do it like this. Now this is going to be the positive and this is going to be the negative end. So I can connect this to the positive, and I can connect this one to the negative. Again, if I want to measure the voltage, I can put it on voltmeter. I have to take this out, put it back on voltage. I can measure the total voltage now, which is the voltage between point A and D. It's going to be around 10 volts. 10 volts for that, which is our source voltage. Then, if I want to measure the voltage of each resistor, I would simply put the voltmeter in parallel with that resistor. So the first one, the voltage is 3.344. The second one is 3.34. And the third one, R3, is 3.34. So these are in series, so the voltage, total voltage, which is around 10 volts, will be divided between these three. And since my resistors are identical, it will be divided by 3. So this is 3.3, 3.3, 3.3. So the total voltage would be around 10 volts. If I want to measure the voltage of R2 and R3, I would simply put it like this, and it will give me the summation of the voltage of R2 and R3. Because R1 and R2, R3, R4 are in parallel, the voltage on these three are equal to the voltage on this R1, which is going to be again around 10 volts. If I want to measure the current passing through these, I can simply again disconnect the positive, put the multimeter again on milliamps, put the terminal in milliamp, and again bridge the gap to measure the total current passing, which is here around 10.6 milliamps. I'm going to show this again. So this current here, 10.6 milliamps current. Now, if I want to measure the current passing each of these resistors, I can simply disconnect R2 from R3 like this. So I disconnected R2 and R3, and again I can bridge it with the ammeter multimeter, so I would have 0.69 milliamps. Again, I'm going to connect R2 and R3. I'm going to disconnect R3 and R4. Again, if I measure this current, I would have 0.69. The current at this point, I'm going to call it point D and point E and this point F. They are all going to be the same because these are in series and they will share the same current, but they will have different voltages. In my case, because the resistors were identical, I had almost the same voltage, but in your case, it's going to be different. And if I want to measure the current passing R1, I would simply disconnect this from R1. You can see that it's disconnected, and then again I would bridge these two spots, make sure that you make a connection, and now you can see I have a current of 9.9 milliamp. So since this is a lower resistance overall, most of the current would pass through R1, and around 1 milliamp would pass through these three, and around 9 milliamp would pass through R1. So this is lab 7.2. You would do lab 7.2, complete all the tables for 7.1, 7.2, and the next one would be lab 2 from the second semiconductor lab. For this one, you need a LDR, and an LDR. If you don't have an LDR, it's okay, you can skip this lab, but if you have it, you can continue with that. An LDR looks like this, and an LDR is basically a light dependent resistor. What does this mean? It means that the resistance, it's a resistor which is depending on the amount of light that you get here, and by changing the amount of light, the resistance of this would change. One way to test this, I could show it to you, is I will put this on resistance, and I'm going to connect this to the resistor. Now, from the multimeter, you can see that it has a resistance of around 1.5 kilo ohms, but if I block this, you would see that suddenly the resistance jumps. So if I put more lights on it, the resistance decreases, and if I block it, the resistance decreases. So in dark conditions, you would have higher resistance, and bright conditions and more light, you would have lower resistance. What is the application of LDR? The dusk to dawn lights that you see that automatically turn on when at night or at low conditions actually work with these diodes. These resistors. They don't have any polarity, so you can connect it in any way. To complete this lab, you simply need the resistor, and we would put the diode in series with the resistor. And then we can measure the voltage. And we have a table with 3 different values, and you can measure the voltage. Voltage here is around for example, in this case, this particular case, with a 4.7 kilo ohm, the voltage is around 7.2 volts. But if I block the resistor, you would see that the voltage changes. On the table in lab 2, you would see it has 3 conditions: dark, bright, and normal. For dark condition, you can just simply block the diode with your finger. For normal condition, you can use the room light. And for bright condition, you can have your phone, the flashlight on, and then you can measure the voltage and the resistance of this. So in this condition, particular condition, I can show you how much the voltage changes if I can connect these. So here, the voltage is 9.3 volts. Then for normal condition, the voltage goes to 7.2 volts. And if I put my finger on it, it will be 3.2. So you can see that darker conditions, the resistor goes up. And you can take this out and measure the resistor and change the lighting condition as well to see it in different lighting condition. And you can measure the current as well. So to measure the current, again, you can disconnect these two, bridge this with a multimeter, and measure the current as well. So again, pretty simple lab. For lab number 3, we need a 1 in 4,000